Hello, physics. We are looking at some more interesting information on waves today. You'll be taking a few notes on day 3, which is about sound waves in substances other than air and sound waves that are outside the range of our hearing. So obtain this note page and begin taking notes. And this is Wednesday. What's the date of Wednesday? I'm saying it's the 19th. Correct me if it is wrong. All right. All right, what I need to explain this day is sound waves travel in substances other than air. Again, sound waves are the longitudinal waves that are compressions, rarefactions, compressions, rarefactions, and so forth. Now, when the sound waves hit other substances, their speed changes. Let me show you some of these changes. See what you think about this. All right, if you have your book by you, you can look, but I'm going to show you. It's on page 363, if that shows up. Notice that the substances have different speeds of sound in different substances. So if you would, Maggie, would you read each of the substances and their speeds of sound? Okay, thank you, Maggie. Now, notice as we went from air to alcohol, and then we went from alcohol to fresh water, and then we went to wood, then to lead, aluminum, iron, and copper. Notice that the speed of sound increased as we changed substances. All right, so the note that I want to take on that is related to how these substances changed and what happened to their velocities. So it turns out that sound actually travels more quickly in solids than in liquids and then in air. So let's make a note of that. Sound travels more quickly in solids than in liquids, and more quickly in liquids than in gases. So it turns out we need atoms that are, and molecules that are compressible to make these clumpings that sound waves require. So therefore, it must be that the atoms and molecules present in solids are more compressible, more easily compressed than those in liquids than those in gases. So I think we have witnessed that to some degree in our life. So like if I had two rocks, pretend this is a rock, and this is a rock of some kind. We'll make it look more like a rock. So we can hear that in air, but if I did this underwater while your ears and your brain were both under the water, it would be deafening. Have you ever tried that? Take two rocks or two hard objects, clank them underwater. You will not believe how loud they are. So, sound travels more quickly in solids than liquids than air. So, we believe that to be true because the ability for these mediums to compress is greater in the solids than the liquids than the gases. So, compressibility is key. So, molecules in solids are more compressible. All right. Turns out, in addition, the other thing I want to say about before we leave sound altogether and switch over to studying light waves, sound waves are, there are all kinds of sound waves, and there are lots of sound waves that we cannot even hear. So some sound waves are above the range of human hearing and some are below. The actual frequency which the human ear can pick up are these frequencies to which the human ear is sensitive. So the frequencies go down from 20 hertz to 20 and up to 20,000 hertz. So that's quite a range that the human ear can pick up. Frequencies to which the human ear is sensitive, 20 hertz to 20,000 hertz. Waves within this band of frequencies are called sonic waves. Sonic waves are between 20 and 20,000. All right, so there are sound waves that are below 20 and above 20,000 hertz. So let's talk about those. If we go below 20, the human ear can no longer pick those up. And those are called they're called ultrasonic. Oh, no, they're not. I was right the first time. I was starting to write it correctly. Infrasonic. Infrasonic waves are those below 20 hertz. So there's nothing magic about these. It's just that their frequencies are long and we cannot pick those up. Our ears cannot hear them. Because of these frequencies, they can do certain things to serve us. So the waves that are infrasonic are unknown to me. So I'll have to get back to that. Infrasonic waves. I have a little chart here, I thought, but maybe not. I'll look. Okay. I do have a chart. Okay, I'll be actually giving, the reason I don't have it in front of me is that I'm going to show something like that with light. So I thought it was with sound. Infrasonic waves, I'm not sure what they're used for. Ultrasonic waves, we've all heard of those. So sonic waves that are above 20,000 hertz are called ultrasonic waves. And I know that pregnant mothers have enjoyed the ability to see sonograms of their unborn child while it's in the uterus, they can take an ultrasound. So this is going to be sound waves that bounce off at very high frequencies and create the image. So we have a picture in our book of an ultrasound, such an ultrasound. Also, there's lots of other tools that use ultrasound waves, ultrasonic waves. There are, have you heard of ultrasonic rulers? So they will take a wave and bounce it off, say, a wall. You point the ruler at the wall, and the waves travel back to the instrument, and it calculates the time it took, and it knows the speed of the sound wave at the given temperature, and then it calculate the distance from you to the wall or other object of interest. So if anyone has one of those, bring it in. I'd love to see it. All right, so believe it or not, we have covered sound waves in substances other than air and sound waves outside the range of hearing. I don't have any more for you to do today, so if there is still time in class, I'd like you to open your book to page 365 and begin reading the next section. So you want to read page 365 and just read on about light and waves until the end of the period. So read 365, and you could read on to 372 if time permits. So 365 to 372, and that's all for today. So with that, we'll close this discussion, and I'm probably missing you a little bit, but not too much. I'm having a good time. I hope that you are surviving. I hope the art competition went well, so tell me all about it. All right, Morgan, if you do a quick check-in with me, I would appreciate that. All right, over and out.